Good afternoon, everybody. Today we're going to talk about problem number 3 of the 2023 US Open Platinum level. So this is a problem of triples of cows. You have n cows with n minus 1 pair of friends that forms a tree. The cow basically you can leave on vacations on day I, cow I left for vacation. Then all pairs of the I's friend, they become friends. So we're looking for triplets of cows, A, B, C, so that they all exist. They're not on vacation, and A is a friend of B, B is a friend of C. So let's look at the first example they gave us, right? So you have 3 cows. One is friend of 2. Okay, 1 is friend of 2, and 2 is a friend of 3, right? So you form a tree like this. Then initially you have the triplets 1, 2, 3, or 3, 2, 1, right? So when first cow left, then you don't have triplets anymore. So how do we solve this? Obviously, what you have is, let's say you have a bunch of things like this, right? So let's say you have something like this, okay? So if this move away, let's move away, go vacation, this and this become friend, this become friend, this become friend. So immediately you're thinking about something that is merging things together and maintain the relationship, right? How do we do that? So if you remember, we had things similar to that in previous USACOs. So let's describe a relationship. Let's say at another node, describe the relationship. This is 1 to 2, right? This is a relationship described 2 to 3. Okay, so what we have is we have those points. So we have original points, which are the cows, and the between points we have relationships. If you look at the second problem, let me draw the second problem for you. So you have 1 to 2, right? 1 have a relationship 1 to 2, which goes to 2. 1 have a relationship of 1 to 3, which goes to 3. And 1 have a relationship of 1 to 4, which goes to 4. So I add a -1 node to describe relationship. The reason I want to do that is when I take this away, right? So when I take 1 away, it goes on vacation. So I will merge those nodes together, right? Merge the open circle, the relationship nodes together. So become a super node, which becomes 2, 3, 4, like that, right? So then we can describe, okay? So now let's look at, so we have, let's make it simpler. So we have, let's say we have node A, B, C, D, E, okay? B and D, they are relationships. A, C, E, they are the original cows. Okay, let me redraw like this. So you have A, which goes to B, which goes to C, which which goes to D, which goes to E. Okay, so in this case, what would be the total number of those triplets you can form? Underneath of this, right? Let's say immediately underneath of each of the cows, let's say you have amount of original cows immediately below this cow, original one. Let's call that is size of, of node, right? So in this case, we have B and D. So then the relationship, then amount of things you will have, you will form a triplet like this, right? So any of those, you can form a triplet when you remove it. So you can have the total is size of B times size of D, right? So B, for example, you have, here you have a bunch of those. D, you have a bunch of those, right? Each of those can form a relationship of that, right? So you basically sum it up, right? You first sum up C is a cow, right? For each of C, right? So B and D are basically for B and D are child of C, right? But don't repeat B and D, let's take a B less than D. I mean, B can bigger than D, and it doesn't matter. Just basically don't duplicate. So that will be one scenario. Okay. So then the second scenario is, what if B and D are the same? Okay. And then the ABC can be anything, right? I mean, not ACE. Those three cows, those are the second situation. Can be anything. So the way is, because you basically pick any of those, right? So you sigma of those B is one of those relationship, right? So you do size of B plus 1 times size of B, then times size of B minus 1, right? So then it could be the third way, it could go like this. The third way you could go like this. You can have B here. On this side, you have A. Then if you look at this, right, you twist this down. You can have C here. Then you have a relationship, which is D. And then you have a cow here, E. Okay, so basically the difference between this and this is they are not at the same level, right? So one is at a lower level. So C is not the parent of B and D. C is a child. So in this case, you can calculate, that is, you take this, right? So this is, you take sum of B is a relationship, right? Basically, you take size of B times, you have to then count all those another relationship thing, which is two distance away. Let's call it the size 2, okay? Size 2 of B. Size 2 of B is how many of those white dot, relationship dots, which are two distance away from this, right? So because you could have something like this, right? So you could have something like this, okay? So then you just add 1 plus 2 plus 3, right? Each of those cases. Then you get the total. Then if I want, every time they remove 1, right? If you look at the smaller ones, every time you remove 1 from the original tree, so this is over n, right? Every time you remove 1, I have to recalculate it. So that is O(n) squared. So that's not good enough. N is on E2E5, right? So, however, we can update all of those. We can easily update all of those. If you go, in every time you remove 1, let's say you first calculate 1. See, every time you merge, this is basically a union, right? You do a union and you can do union find. So we know how to do that trick. So basically you do this instead of, so you do, every time you update means you remove, when you remove 1, okay? So what you do is you have to remove, every time you remove 1, you remove the path, right? For the node. Remove the path for the node, right? You do that. Then you have to update, right? You have to update size of x, that we know and you can easily update, right? Every time you remove 1. And then you have to update size 2 of x, right? So that you can do. But remember, you have to, sometimes you have to remember, you have to find the parents, right? So this one you have to find this parent, and this one you have to find the white one's parent. So you basically have to find, black cow's parents, which is in the tree is this one. You need find immediately the black one, right? Immediately above it. Okay, then you immediately find the white one immediately above it. Okay, so what you need to do is, if you have, you do union find, right? You do find x, that is because you did a merge. Then you do the parent, right? So that is the black node immediately above x, right? This is the car, right? Then you do the size 2 of that. You update this. You also need to update. Remember, you also need to update the relationship one. So you do basically find x, right? Parent. This is the black node, right? Then you do find. Then that is a relationship one, right? Then you update this. Right? So that all those can be done by union find, right? So that's not difficult. So you do the merge, you do the union find, and all that stuff. Okay. So once you do this, then you get and basically square root of complexity. Okay. So this problem is not that difficult. You just need to remember the trick. This trick we used before, right? When you have a relationship that you want to merge them, you add additional n-1 dummy nodes that describe the relationship so that you can merge them together. Then you look at situations, right? There's like 3 types of situations. One is this situation, or the same as this situation, right? You want to merge them. So the second one is if they're the same. The third one is unbalanced situation. Right? So each of them you can calculate their sums. The only remaining thing you want to do is how you improve from n squared to n log n. You do so by using the equivalent of a unified. Okay, so that's this problem. So hopefully you are able to solve this. If you didn't, after this class, code it. Then next week we'll start going to talk about the 2022 ROI class, ROI problems. As usual, there are 6 problems. We're going to talk about one problem a week. So there's still 6 weeks of class left before the summer break. I would like you to start to working on problem number 1 this week, fish. And then every week we will work on one problem. Okay, good luck, and we will see you next week.